Okay guys, we're going to start class with a class opener, of course, of what we had yesterday for homework, solving absolute value equations. And I hope that you guys remember from yesterday that when we solve an absolute value equation, there's really two situations. There's a positive situation and a negative situation, which usually leads to two answers. So what I always start out with is writing pos and neg. And of course, you draw a line through it just to separate your work. Now the positive situation, I hope you guys remember from yesterday's notes that you write it exactly the way it is, but without the absolute value signs, right? Without these little lines right here. So we're going to write it exactly the way it is without the lines. That's going to read 2x minus 9 equals 3. And the negative situation, it's also going to be the same exact thing. The only difference, it's going to be the same thing, 2x minus 9, but instead of equals 3, we're going to have it equals negative 3. So on the negative situation, all you do is simply put a negative sign on the right side of the equal sign, on the right side of your equation. So anyhow, we have now two equations, two simple problems that we need to solve. So let's tackle one at a time. Let's go for this positive situation one, okay? So how do we get rid of that minus 9? We're going to do the opposite of minus 9, which is plus 9. Again, 9 minus 9 cancels out at 0. What you do to one side, you do to the other. 3 plus 9 is 12. So we have 12 right here. Remember, the equal sign divides the equation up into two, the left side of the equal sign and the right side of the equal sign. So that equal sign really does come down right here. And also this 2x comes down. I should probably write it all in black. I'm sorry. 2x equals 12. So what do we really have here? We have 2 times x, and we don't want 2 times x. You just want x by itself. That's the whole goal of solving an equation. So let's get rid of that 2 times, the multiplication of 2, by doing the opposite of multiplying by 2, which is dividing by 2. And what you do to one side, you must do to the other to maintain the balance, the equality of both sides. So what we really have now is x equaling 6, and that is our final answer, and this is just half of what we need because that's barely the answer to the positive equation, the positive situation equation. Now let's go to the negative situation equation. We are going to get rid of that minus 9 by doing the opposite of minus 9, which is plus 9. And what you do to one side, might as well zoom in and focus in on this. What you do to one side, you do to the other side, so we're going to add 9 to the negative 3 as well. And of course, negative 9 and 9 cancels out. We have the 2x left over. The equal sign comes straight down. And negative 3 plus 9 is positive 6. So once again, we do have 2 times x. We don't want the multiplication of 2, so let's get rid of it by doing the opposite of multiplying by 2, which is dividing by 2. And what you do to one side, you must do to the other to maintain the balance. So we really do have the x all by itself on the left side. We have the equal sign that comes straight down again. 6 divided by 2 is 3. Ladies and gentlemen, we have our two answers to this original absolute value equation. The two answers are 6 and 3. So if you took the 6, the value of 6, and plugged it in, that would be 2 times 6, that's 12. 12 minus 9 really is equal to, actually 12 minus 9 is 3, but the absolute value of 3 is really equal to 3 anyway. Now you could take the 3 and plug in the 3 right there. 2 times 3 is 6. 6 minus 9 is negative 3, and then the absolute value of negative 3 is also equal to 3. So as you can see, both of these answers work. You have to state both of them to get full credit. Let's move on to number 2. On this one, we're going to set, again, the positive and the negative situation. Of course, we're going to draw a line right between it to separate our work, to separate our two equations. Remember, for each one of these, we're going to end up solving two equations, the positive situation equation and the negative situation equation. And if you're wondering, how do I get that positive situation equation? You just rewrite it exactly the way it is without these guys right here. Okay, take these guys off and you'll be good. So let's write it exactly the way it is. 3 minus 2r equals 9. Perfect. Now for the negative situation, same thing. 3 minus 2r equals, but instead of 9, we're going to put negative 9. For the negative situation, once again, you have to add on a negative sign to whatever's here on the right side. Anyhow, let's solve both of these. Let's focus in on the positive situation here. You want to get r by itself on one side. That's the goal of any equation, to get the variable by itself on one side. You do not want this negative 2 that you're multiplying by, and you don't want this 3 that's all out here all by itself. So of course you get rid of that 3 first by doing the opposite of positive 3, which would be subtracting 3, right? Or negative 3, however you want to think of it. 3 take away 3 is 0. What you do to one side, you must do to the other to maintain the balance. So what do we have on the right side of the equal sign? Again, the equal sign comes down. On the right side, you have 9 take away 3, which is 6. On the left side, what do we have left? We have a negative 2r. We're just going to bring that right down. So there's a negative 2r on the left side of the equal sign. Did I say it right? I don't know. Hopefully you guys are understanding me here. Anyway, now we have a simple equation, a one-step equation. You want to get rid of this negative 2 times r. So how do you get rid of the multiplication? How do you get rid of the multiplication of negative 2? You divide by that same exact value, negative 2. Divide by that same exact value, negative 2. Some people just put divided by 2, but that doesn't get rid of the negative sign. You want to get rid of the whole thing, so you might as well divide by that whole value, negative 2. So divide by negative 2, divide by negative 2. The negative 2's cancel. You have an r left over. The equal sign comes down, so r equals 6 divided by negative 2 is negative 3, and that is our final answer. But that's only half of what we need, right? That's the positive situation. Let's go to the negative situation here. The negative situation, we're going to get that 3 out of there from the left side. Again, subtract 3. What you do to one side, you must do to the other. Subtract 3. Our new equation is negative 2r equals negative 9 take away 3 is negative 12. And once again, we need to get rid of the multiplication of negative 2 by doing the opposite, dividing by that exact value, negative 2. What you do to one side, you must do to the other. What do we have left on the left side? The nice, beautiful r all by itself, and that's what we want. That's our goal, to get r all by itself. And negative 12 divided by negative 2 is positive 6. So we are done. We have both answers to number 2. Number 3, I mean, we could check the negative 3, plug it in, it'll work. It'll give you 9 as an answer. You can plug in 6 and it'll also work. It'll give you 9 as an answer. If you have time on your quiz or test, you have time left over, instead of turning it in, I would go back and actually take my answers, plug them in, and see if they actually work. Okay, let's check out number 3 here. Number 3 is different than numbers 1 and 2. Number 3 is not even on our homework. Why not? Because all of our homework questions have the absolute value all isolated. There is no times 3 out in the front. There is no minus 1 at the very end. But I threw this one out there just so you could get like a head start for future problems. So step 1 that we explained yesterday was to isolate the absolute value. It's kind of like pretending that you had a big giant X right here, okay? Imagine that, let me just do a big giant X. So let's say this said 3x minus 1 equals 20. That really means 3 times x minus 1 equals 20. So pretend that this absolute value of 2g minus 5 is really just a big giant X. And how do you isolate it? The way you would solve for x. So imagine you solving for x. What would you do? You would add 1, and then divide by 3, and then divide by 3. So it's the same process. Let's add 1 to both sides, plus 1 here, plus 1 there. And what do we have left? We have 3, and instead of x, we have this absolute value of 2g minus 5, close absolute value, bring down the equal sign, and 20 plus 1 is 21. So for my final step, I need to get rid of this multiplication of 3 by dividing the whole thing by 3, and of course that'll cancel out. Again, you're treating this kind of like if it were a big giant X, right? So if you did have 3 times x, you would get rid of the 3 times the multiplication of 3 by dividing by 3. And of course, what you do to one side, you must do to the other, divided by 3. So what's our new equation? Our new absolute value equation is 2g minus 5, and that's in the absolute values, that is, equals 7. And now that we have the absolute value isolated, now we could actually do the positive and the negative situation here. So let's do that. Let's draw a line down through it. And the positive situation, once again, is writing it exactly the way it is without the sticks, without the absolute value signs. And the negative situation is the same thing, 2g minus 5, but instead of a regular 7, it's a negative 7, okay? And let's solve both of these. Let's focus on the positive situation. So in the positive situation, we're going to get rid of that minus 5 by doing plus 5. And what you do to one side, you do to the other side. So you will have 2g, the equal sign comes down, 2g equals 12. And final step, I really have 2 times g, so I need to get rid of that multiplication of 2. I'm going to divide by 2. What I do to one side, I do to the other side. I will have g equals 6. That is one answer. Let's go to the negative situation now. This one, once again, we're going to get rid of the minus 5 by doing a plus 5 and a plus 5. So what do I have left? I have the equal sign that divides my two sides. On the left side, I have the 2g that came straight down. The negative 7 plus 5, that is a negative 2. So my final step here is to get rid of the multiplication of 2. I'm going to divide by 2. What I do to one side, I do to the other side. G equals negative 1. So those are my two answers, 6 and negative 1, to the original ugly looking absolute value equation. Okay. So 6, if you were to plug in 6 right here, 2 times 6 is 12, 12 minus 5 is 7, 3 times the absolute value of 7, that's just 3 times 7, that's 21, and then minus 1, it really is 20, so 6 really does work. If you plug in negative 1 right in here, 2 times negative 1 is negative 2, negative 2 minus 5 is negative 7. The absolute value of negative 7 is 7, and 3 times 7 is 21, and 21 minus 1 is 20 again. So as you can see, both of these work. So both of those are your solutions to that one. Will you have any like that on the homework? No. Will you have any like this possibly on the quiz Friday? Maybe. Okay. So make sure you understand that you first have to isolate it. As you can see on number 1, there was no number out in the front, no number added or subtracted at the end. So this one's already isolated for you. Step 1's done for you. Same thing here, it's already isolated. This one's the only one that has a 3 out in the front and a minus 1 at the end. You have to get rid of the minus 1 and the 3 before you start setting up your positive and negative situation. So I hope this video helps.